it is time for an ambient project, and one of my favourite projects at this time of year, which is round about the Christmas season, is hacking strings of tungsten fairy lights to convert them to LED. And what happens when you do that is you end up with the whole string taking less power than one original tungsten lamp did, plus you get to choose the colour of LEDs you put in. And if you choose later on, if the set runs for a long time and they gradually lose intensity, although they're not run at high current, you can just swap in new LEDs. It's extremely serviceable, and it's one of these things you can just leave it lit 24/7 without worrying about the power consumption, because it's less than $1 a year. It's much less than $1 a year, or pound, or euro, whichever your currency is. So this is a 20 tungsten lamp set. I won't plug it in because I've actually cut it down from a 100 lamp set, and that would be catastrophic for the lamps. And I do want to keep them. But what I'm going to do is I'm going to add a little current limiter and a bridge rectifier. Now I was going to use you get the standard little bridge rectifiers that basically look like a cylinder with the 4 wires coming out. I was going to use one of those, but I can't find them anywhere. I know I've got them here somewhere. I've got lots of different rectifiers. I just couldn't find them. So instead, I have improvised a little roughed up bridge rectifier. But that's a straightforward thing to make, and it just means that you can make stuff out of junk, and that is also good. So we have 4 series resistors. Now in the past, just for ease when I've been using this, I've put a resistor on each of the legs, but there is a slight downside to that. If you were to put a resistor here and there, then it means that if something terribly catastrophic went wrong with the bridge rectifier, which is extremely unlikely, it means that the 2 resistors that were on this side of it would potentially be overloaded and would go up in smoke. So instead, I'm putting both resistors on the AC side, and I've chosen the resistors so that even with a full dead short circuit, basically speaking 4 resistors connected across the mains, the power dissipation is roughly half their rating, so they could sit there and simmer gently forever if that went wrong. But it's the current limiting with the resistors, a bridge rectifier, and then literally it's just across the LEDs. You do have the option of putting a capacitor and another resistor in if you want, but you don't need it with a small number of LEDs. There is that slight bit at the bottom of the sine wave, if that's the full wave rectified sine wave, down there, that they will go out, but the flicker is not really noticeable, as you will hopefully see later on. Certainly I've got a set next to me that have been lit for about 8 years, 10 years, and they're fine. There's no really perceivable flicker off them. So the resistor value in the countries that have 220 to 240 volt, let me zoom down this. This is going to be better. Let me zoom down a more controlled manner than that. Let me actually focus down onto that. That would be better. 220 to 240 volt used for 22k quarter watt resistors. Quarter watt. If you've got 100 to 120 volt supply used for 6,800 ohm resistors, with the added advantage you get twice the current, because it's much easier to drop using a resistive dropper in the lower voltage. So what I've done, I've started off by making a bridge rectifier just by twisting diodes together. Let me get this out the way and show you this. I'll bring it up closer so you can see that, and I'll zoom down on it even further. So I've literally twisted the wires with the 2 banded ends towards each other, the 2 non-banded ends towards each other, and then twisted them together at the sides. And that means this is positive, this is negative, and that's the 2 AC inputs. And then to make it easier to fit into a suitable enclosure, and I have made a suitable enclosure, it doesn't have to be 3D printed, but I so happen to 3D print mine. It's a very simple print, but you can also just use the cap of a pen or whatever. Yeah, they're combustible that way, but it's not going to get that hot. But what I did was, if this is the positive, this is the negative, what I did was I grabbed the positive and negative in these fingers and the AC in these and just pulled it like that. And then got the AC ones and connected the resistors to them so they run up in parallel like that. It just means it's taking much less space. And I marked this one with a little red dot to make it visible that it is the positive. Now let me just zoom down here and focus on that and then zoom back out again. Right, so what I'm going to do now is I'm going to solder some leads onto these, and I'm going to also use heat shrink. Heat shrink sleeving. So I'm going to cut the plug off. Don't do this with the power on. Some people have done that. It makes a very loud bang, very, very scary, quite funny though. I've marked this one here. So this is going to be where I cut the cable. These snips, I've been abusing these side cutters. I'm going to have to get more. You know what? They're so cheap off eBay. Just buy tons. It's fine. And I'm going to strip these wires. These are double insulated wires, by the way. They've got 2 layers of insulation, white on the inside and green on the outside. This is something that's very sadly missing on cheap Chinese lights. And it's quite dangerous, actually. Because it means that you can, well, it's bad enough. There's quite often with the cheap Chinese lights, there's just bits of copper sticking through anyway. They're so dangerous. They just don't have standards. That's fine. We know what to look for. We won't die. So, I'm stripping these and I'm going to twist them. They are most likely real copper. I'm kind of suddenly doubting that as I try and twist them and they don't twist. Maybe they're not. Maybe they're copper-coated aluminium. I think they are real copper, these ones, which is nice. And as such, they will take solder admirably. So let's start with the AC connections. Where's my solder? I should zoom down a little bit. And we'll tin these in readiness for soldering them onto my current limiting device. I have these little strings everywhere in the house, just lit 24/7. They're very nice at night. They just cast a very gentle glow, which is nice. And they are fully serviceable. And if you have a 3D printer, not everybody has a 3D printer, and that's fine. If you have a 3D printer, you can also make caps for them. I have a video showing with the script the caps. Don't actually use them with tungsten lamps. They're too hot for these caps probably, and they'd probably make them malform. But you can print caps in a selection of shapes and sizes. Right, so I'm going to solder these on. I'm going to put a bit of sleeving across first. Because these are going over the resistors, onto the resistors, I'm going to put longish sleeving, because the sleeving will also slide over the resistors. It's just extra protection against kabooms. I had another bit of sleeving, there it is. So I shall slip that over there. I will be abbreviating this video as much as possible, so it's not too long. Now I'm going to put the first AC wire onto there and reflow, because I've tinned them both, reflow them together. It would be quite nice to apply the solder directly to this, because one of the important things about soldering is the liberation of flux into the joint. It makes things better together. But it doesn't really matter too much if you've already pre-tinned them, so they're both coated in solder, as I've done. Hold it there, let it cool. Okay, now I shall slide the heat shrink sleeving down once that's cool enough, so it doesn't instantly try shrinking before I'm ready to shrink it. I should nudge that back. I just want it a little bit over the green, but not too much over the green of the cable, because I want to pot this in resin afterwards, just to insulate it. It is mainly bang prevention, to prevent adjacent wires shorting together. Looking good. I might just shrink them down now, in fact. Hold on. Here comes the heat pen. So I shall just apply a bit of heat and shrink them down. That's the AC connection made to my bridge rectifier, my crude hand-assembled bridge rectifier. Then I'm going to get the ends going to the LEDs. I'm going to tin those. Splashed solder in that. This is one of these projects that if I made the full video, it would be enormous. And I've generally found that when I make huge, long videos, this wire is not twisting. That's making me very suspicious. These might be new copper-coated aluminium ones. I could be wrong. I'm so tempted to get a bit of this and just give it the aluminium test. It doesn't really matter too much. As long as it takes the solder on the copper on the outside, that's fine. I'll put a bit extra on. Load it up a little bit. And then I shall put a bit of heat shrink sleeving on that. I shall cool it down with my fingers, with the blood flow taking the heat away from the solder, as one does. Right. So one of these I put a little black dot on it to remind me. It doesn't really matter too much. I probably can't see the black dot. I've probably cut it off. Oh, I think I have. Black dot and green. It's not really a good idea, is it? Tell you what. I do want to find that, because otherwise it's going to nuke the first LED I put in. When you put the LEDs in these, they have to be in the correct polarity, obviously. Otherwise they won't light. And in the case of the gallium nitride type LEDs, they seem very intolerant of reverse voltage. It tends to damage them. Right, tell you what, one moment please. Sorted. A little red dot in this one just to show it is the positive, and that will be going to the positive, which the bands point towards. So I shall just fold that out a little bit. I shall fold them both out just to make them more accessible, and also to stop me damaging the adjacent connections with the heat from the solder iron. And they are already tinned, those, so I should be able to just flow them together. So I shall flow that one onto there. Pause momentarily till it sets, till it cools, and then that one onto here. Quite tempted to put a bit more solder in that as a precaution. I will put a bit more solder in that as a precaution. Let's see if I can make everything go wrong at some point in this project. That sometimes happens. It's the peril of projects. Much better if it's just a fun project than if it's something at work and things go terribly wrong, because that is bad. Much more pressure when things are going wrong at work. When things don't work as planned and you have to redo things. So now that that has cooled at that side, I'm going to put the sleeving down over that one, if it will fit. It's a close fit. It has gone wrong. It's fine. And then this one, I shall put the sleeving down over that. Oh, that fits a lot better. And I shall shrink them on. Things that have gone wrong at work, actually a Disney incident comes to mind. When we were testing a ride called Armageddon, and it had these jets of liquid nitrogen and superheated steam that actually came, that was actually liquid nitrogen being sprayed into superheated steam. Disney does that a lot, particularly definitely at Disney Paris. And I was standing over one of the jets just because they said, right, we're going to test, and I said, right, I'll stand over one and see what it feels like, you know, getting hit by the jet. And the pipes, the superheated steam pipes, were actually full of water, and I got drenched. Water was dripping out my pants. It was very impressive. And then the sudden horror of the person who'd come up with that effect, realising that was not going to work and he was going to have to find some way of draining the water out of them. These things happen. Okay, this is ready to actually pot now, so I'm just going to make sure that these are kept separate. And I'm going to mix up some resin, pour it into here, about halfway up, and then I'm going to put it in. And then if necessary, I shall top up a bit further. Well, I will have to top up a bit further. I may have to fill it a lot fuller than that, because it's going to get displaced out by the stuff that's being put into it. Right, tell you what, one moment please, I'm just mixing the resin. Okay, let's mix the resin up. 2-part resin, I quite like 2-part resin, it's very useful. I've mixed up plenty because it's better looking at it than looking for it. Incidentally, this arrangement, the diodes, the first time I came across the folded diodes like this was actually in a commercial lighting product. It was inside the end of the LED rope light connector. You know, you get the plug that goes to the little cap that goes onto the end of the rope light and it has the rectifier built into it. That's what it was. Nowadays they often put it in line as a blob and it's a much beefier rectifier, but back then it was literally just 4 1N4007 diodes. But they also had little plastic spacers between them before the injection molded them into the plug. Very simple. I think they switched to the bigger rectifiers due to failures at the ends because people used to drive quite long lengths of it. Right, what's the chance of me making a huge mess? It's huge. I will make a huge mess. Let's try and pour this into my little pink plastic tube. The 3D printed tube here, by the way, is literally it's an open SCAD. I'll put the file in the description. That's the best bet. It's literally a outer cylinder, and then an inner recess, just 2 cylinders. The inner recess is subtracted from, but before it's subtracted, it's a bit thinner to make the inner core, and it's also lifted up by 1mm to make a 1mm base. Have I filled this up to the brim? No, I've not. It's fine. This is going to squirt out everywhere, isn't it? Do I have something to deal with the huge mess when I make it? No, I don't actually. Oh dear. Not to worry. It's fine. I shall deal with it when it happens. I'm kind of intrigued to see, this is PLA, it's quite a low temperature plastic. I'm intrigued to see, is the 2-part resin going to actually get hot enough to actually make this melt? That is another thing that's going to be interesting to see. I think that's enough. I think that looks alright. I should put this stuff out the way. And then plunge my mess into it, like this. Oh. Plunging. I wanted to squirt up enough. Oh, it's hit the bottom. And it's not squirted out enough. That's okay. I shall get the vise of knowledge up. Hold on, where's the vise of knowledge? Where is the vise of knowledge? It's hiding. One moment. There is the vise of knowledge. I shall gently clamp this in the vise of knowledge and then attempt to drizzle more resin in to fill it up to the brim. Have I got resin in my fingers yet? I've not. This is a surprise. Okay, I'm going to scoop some resin in and just drizzle it down the side here. Oh, almost. It just tried to escape there off my little wooden stick. The wooden stick is stolen from Conrad's coffee shop in Ramsey, where I usually drink coffee when I'm up at sociable hours. Oh, I'm making a huge mess here. Oh, look at the mess I am making. It's going everywhere. This is what happens with resin. It goes everywhere. Handy hint, if it's too stiff because your ambient temperature is low, you can heat it up gently and it will tend to flow a bit better. I'm going to lift this out because it's starting to pour over the side. Yeah, resin, it's fantastic. One of the best things you can do with resin is just make last minute changes to something and then regret it horribly. That is the nature of resin. I should pause because I'm going to have to pause because this is going to have time to cure and you definitely don't want to watch the resin curing. Right, tell you what, I think that's okay. I think that's enough. That is my little module. Rightio. One moment, please. The resin has now cured and it is time to test it by plugging it in. At this point in time, I'm going to cut that cable tie off. At this point in time, being careful not to actually cut the wires in the process. These snips are wrecked. I should get new side cutters. I shall order some more right after this video. One can never have enough little side cutters. If I plug this in, it's either going to go bang or nothing's going to happen. Nothing happened. This is a good result. If it does go bang, that's just a moment. Now, you'll notice these lights have not lit. There is a reason for that. It's because the current flowing through the circuit is now absolutely minuscule, but this is where we put the LEDs in. So you unplug one of the lamps, you can leave it plugged in while you do this, and you pull the lamp out of the holder. Before you even start this, it's worth checking, because sometimes these lamps are actually glued into these holders, and that's rubbish when they do that. Now there's another thing to note. Some LEDs you buy online have very short leads, and if I put one of these short lead LEDs in, it doesn't even protrude through the back. You're going to have to get the ones with the long leads. So look for the eBay listings that show long leads and then hope that that's actually what you get. So you put the LED in. Let me zoom down this. You put the LED through, with the leads going through the 2 holes, and then you fold it back like this. Then you get a sharp pair of cutters and you turn it with the blade pointing up the way with the open end down the way, and you rest on the little ledge here and you just cut in at an angle. The main thing is that you want to cut it just a little bit short so it doesn't actually ride up the side of this, because if it does, it can actually make the lamps very hard to put in, and also very almost impossible to get back out again. And you do want to make it serviceable. Now, this dot I put in this should theoretically be negative. The little anvil inside the LED should be negative. There's no harm in marking it with what was the shorter lead, but if I put this in, the LED has lit up. That's a good start. Now I'm going to do the same with all the other ones, and I'll be back in a moment. 1 moment, please. The LEDs are now all in and lit. Let's do some experiments. Let's turn the light off for a start and take the exposure off, and yeah, you can see a slight shimmer there. They're not super mega bright, but that is by design. Oh, there's a bit of variation in colour as well between them. So let's do some experiments. Let's put in some alternative LEDs. Actually, you know what? Let's start by accidentally, deliberately, reversing one of these LEDs. So I think this is the negative. Hold on, I'm just trying to see through the housing. Is it easier to see this one? One of these LEDs is about to meet its maker. I'm going to shine a light through it just to see there it is. The anvil of the LED, the bit that holds the chip, is a negative. If you're going to swap LEDs a lot, make a mark on each lamp holder with a Sharpie just to remind you what's negative, and I'll show you why. I'm going to unplug this LED. If I can, it's unplugged. Then I'm going to turn it round and put it in back to front. The other LEDs have lit, this one is not. Quite often with gallium nitride, this LED will now be dead. Just so you know that. It's just a weaker technology. Oh, look at the slight fuzz there, is the beard bouncing up and down. Let's put in some other LEDs. So this one is, I don't know what this one is. Red. This is a colour changing one. The colour changing ones might not work stably on this because it is passing through a zero crossing point that is going out, but this one is working. But you may find that they suddenly randomly reset. But you can use the colour changing ones. What else have we got here? We've got this one, which let's get the right way round. This one is a red LED. The red LED is it's the older technology. I think it will survive being put in back to front. So it's being put in back to front, turn it round. It has survived. Next candidate for experimentation is a very popular LED in China and India. It's the alternating colour LED, I think. Red and green. May not be stable, but in this case it does seem to be okay. Sometimes they require a little capacitor just to provide persistence of current over the when it's going through the zero crossing point of the sine wave. The next LED I'm not so sure about. I've not tried this yet. This is a flashing LED. But because when it's off, it goes open circuit, it might not like the voltage across it. What's it going to do? It's not going to flash all the LEDs. Well, it is flashing on and off. That's quite interesting. What happens if we stick it in back to front? I'm surprised that's working. The other LEDs are fluctuating intensity with that. But it's not an ideal thing because when it goes open circuit, the voltage across it could be quite high. It will be causing some avalanche. What happens? You put it in back to front. If you can get it in back to front, hold on. Doesn't light, turn it the right way around. Oh, it still works, that's quite good. And that just leaves covers. You can make these covers. As I said, I'll provide a link to it. There's a video showing you how to make these covers in a 3D printer. You can make them, you can scale them up any shape and size you want. I've put the files up for that, and you'll be able to download the OpenSCAD script for that. And as before mentioned, the OpenSCAD script for this very simple shape, I'll just stick it in the description down below. But this is it. Now, watch your eyes. The light is coming back. And the light is back. One other thing worth mentioning, this originally started off as a 100 LED set, but I wanted to make it, abbreviate it down to a smaller number. But you can, particularly if you end up adding a capacitor and a bit of extra circuitry, you can actually run very long strings of lights. It's limited, but because they're all in series, by the typical forward voltage of an LED at this level is about 2.5 volts at this current. So it's limited by what your local supply voltage is. On 240 volt supplies, we have the benefit we can run longer strings, but you can basically, with these lamp holders, you can push the little strain relief down at the back here by putting a fine screwdriver between them and being careful not to actually damage the insulation as you do so. You can push it out, and then you can actually physically detach the contacts in here from them, and you can actually splice sections in or out as desired. The disadvantage for us in the UK is that in America and other 110 volt countries, you'd have twice the intensity because it's just that easier to drop current over resistors when you've got a lower voltage to start off with. Oh, that one has gone berserk. Did you see that? Did you see it going berserk? It is. It's being affected by the light from these lights here. When it's pointed directly at one of the bench lights, it goes berserk because it's got a light sensitive chip in it, and because it's in the sort of on the borderline of operation. But that is it. It's a nice project. It's a fun project, and you can just swap colours as desired. When an LED fails, just swap a new one in. Change covers, change LEDs. That's entirely up to you. So another thing that's worth mentioning is, because of the high value of the resistors in these, certainly on the 22, well, let's work it out. Because there's 2 resistors in each leg, the current, if you were to actually touch a bare connection, the maximum could be 240 volts divided by the 2 resistors, 44,000 on each leg. The maximum current could be 5 milliamps, which would give you a very noticeable shock, but it wouldn't go much beyond the sort of wrist in terms of the current density. You wouldn't get locked on around that. It wouldn't be life-threatening. In America, 120 volts. But what did I say for America? 6,800 ohms. 6,800 ohms times 2 equals, say, 13,600. 120 divided by 13,600. Equals about 8 milliamps. That would be more severe. That would be quite a zing, but that's only in extreme instances, depending on where you touched it in the string and if you actually touched a live wire in the first place. So that said, they're actually pretty safe, and the use of 2 resistors instead of just 1 also makes it even safer, because that's a built-in sort of failure prevention to do that, to put multiple resistors in series. But that's it. It's a good project, and these, let's test the power. One moment. The power is 0.5 watts. Power factor is near unity because it is mainly a resistive load, and this will get warm, but it won't get super hot. It will just get gently warm. Current is 2 milliamps, just as predicted, in fact, which is quite nice. It's a very simple circuit. And that is it. So it's quite a fun project to do. It's quite therapeutic, changing the LEDs. You'll see if you've got the colour changing ones that they do go a bit unstable, but that's just a quirk of these, of the fact it's not smooth DC it's getting. But that's quite neat, the fact it's doing those weird things as well. But that's it. Nice fun project, very easy to do, and of course you can print off the caps to make it your very own custom set of lights.